Welcome to Statistics in Real Life. My name is David Britz, and I will be your instructor for this course, this set of 24 lessons. And my objective here is to cover the subject of statistics in a way that I've always wanted to do in my classroom, but was never really able to because there are always certain topics you're mandated to cover in very particular ways. And more particularly, there's a big emphasis on formulas and calculations, and those are very important, of course. But I want to approach statistics from a more real-life perspective, because one of the main reasons that I like teaching statistics is because we can hit the ground running on day one with real-life topics. And that's what we're going to do here. So this first lesson is just going to be a brief introduction, and I'm going to go over all of the 23 lessons that we will be, all the 23 lessons following this that we will be covering, and I'll just kind of give a brief overview of the topic. And so this is not going to be quite like the statistics I would teach in my classroom. I want to try to avoid formulas wherever possible. Of course, they're necessary to a point, and I will show you formulas. And I will show you calculations. So in terms of preparation, what do you need to know coming into the course? A basic knowledge of algebra is useful. You don't necessarily have to be great at it, but just a general familiarity. We're going to be using calculators a lot in this course. So there's not a whole lot of hand calculations or anything like that. There's not a lot of algebra in here. There's not a lot of pre-calculus. So, we're not going to be, there will be some basic equation solving, but not too much. It's going to be mostly arithmetic calculations. So if you're a little weak on algebra, that's perfectly okay. I want to try to stay away from formulas as much as possible. When we get to some of the later topics, such as confidence intervals and hypothesis testing. If you've taken a statistics course in school, you probably are used to seeing a lot of formula sheets and tables where you have to look up a lot of numbers. And I will be covering that just because I think it's important for you to at least understand where the formulas come from. But at a certain point, professional statisticians do everything by computer. And you use a computer program or an app to get the statistical results, but then the knowledge of statistics comes in interpreting those results. It's very similar to when you go to the doctor's office and have, let's say, a blood test. Okay? When they process the sample, when you perform the actual test on the blood, they don't do it by hand. I mean, they have computers and programs to output the numbers. None of that is done manually, but you still need a medical professional to interpret the numbers. And that's what I want to focus on in this course. Not so much the formulas. I will go over the formulas, like I said, at least briefly, so you can kind of see how everything fits together. Because I think that's important. You don't want to if you're just plugging things into formulas, I think it loses a little bit of meaning. So I'm going to try to tread a fine line between showing you the math to a limited extent, but not overburdening you with it. So we'll see how that goes. So what is statistics anyway? Statistics, and you can get differing definitions of this. Statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. Okay, so let me kind of expand on that a little bit. When I hear complained about, well, when am I going to use statistics? I have to be thinking, are you kidding? I mean, statistics are all over the place. If you follow a sports team, an NFL team, you see all sorts of statistics, passing numbers, rushing numbers, baseball, batting averages. Anytime you look at the results of a political poll, you're doing statistics. Every time your instructor computes a class average or a GPA, that's a statistic. So statistics is everywhere. And it's collecting and doing the calculations is one part of it, but you also have to be able to do inferences from statistics. And that's how I kind of divided up the course into the individual modules. We're going to look at data. Incidentally, I put this definition. Data is a plural. So if you ever ask what the plural of data is a plural. So datum, is singular, data is plural. I mean, a datum is an individual number or data point. So I'm just going to kind of go through just a 30,000-foot view. That's my goal today. Just go over kind of the 30,000-foot view of what we're going to be going over. And then in lesson 2, we'll start with some of the preliminaries. And that's what the first module is. So preliminaries, lesson number 1, again, that's what we're in right now. I'm just kind of going over the outline. Lesson 2, population and samples. So we're going to get into discussing what a population is and what a sample is, because our goal eventually is we want to make determinations about a population based on a sample. That's what statisticians do, because whether you're doing a drug study or a political poll, you don't have access to the entire population. So we need to talk about samples and how samples are chosen. And I'm going to go over in more detail descriptive versus inferential statistics. And just real quickly, descriptive is actually describing the data, as the term suggests, and inferential is drawing conclusions from that. And we'll talk more about that later. Displaying data is the last lesson in that module, and we're going to talk about how to make it visual. Frequency tables, histograms, bar graphs, pie charts. How do you visualize a data? Because you've got to do that first. I mean, you can make a lot of conclusions just by seeing a graph of the data. So we're going to talk about graphing. Speaking of descriptive statistics, that's going to be the next module, covering lessons 4 through 7. So this is where we talk about, as the name suggests, describing data. So measures of center, measures of spread. Where is the data centered? How homogeneous is it? How heterogeneous is it? How varied or unvaried is the data? We're going to talk about relative position, percentiles. How do data points relate to other data points? Some of these terms, some of these terminologies like z-scores, I'm not going to discuss that right now because it's going into, we'll certainly see that in these lessons. So don't worry if you don't understand all these terms right now. We're going to cover this very closely in these lessons. So that's what the second module is. How do you describe data? Where does data fit in with other data points? Box plots, box and whisker plots, how to tell whether you have unusually high or unusually low data points. How do you describe data? In the next module, which I kind of have a little bit on this page, in the next module, we're going to take a slight detour and talk about probability. And you might ask, well, why probability? Well, you notice whenever in a lot of statistics courses, they're actually titled probability and statistics. At least in high school, I think it's often like that. And the reason is they are very closely intertwined. You can talk about probability without talking about statistics. You can't do it the other way around, because let's think about what statistics is. Statistics is the science of uncertainty. You have a sample of data, you want to make inferences, and so what you're really talking about is the probability that a hypothesis will be true, or the probability that, well, the population average is going to fall between these numbers if the sample average is a particular number. So probability and statistics are closely intertwined. So we're going to take a look at probability. I'm going to try to keep this as formula-free as possible, because I think one of the most difficult probability is a notoriously difficult topic when you take a typical statistics class, and I think that's because of the formulas, and a lot of students get the formulas mixed up, and it's easy to do. So I'm going to try to, how do I say water it down, but I'm going to try to explain things more from a visual, logical standpoint. I'm not going to go into probability as deeply as I would in a typical college or high school level statistics course. I'm going to try to keep it very visual and very general. Next module after that, lessons 12 through 16, are on distributions. Now, basically what we're going to be looking at is the intermediate stage between descriptive and inferential statistics. A distribution basically means how are data points spread out? Are there a lot of very small values, a lot of very high values? Is it pretty even? Is your data in a bell curve, meaning there are a lot of points very close to the average, a few high and a few low? So that's basically what a distribution is. And we're going to talk about how data is distributed. We're going to talk about specific distributions and how that relates to the descriptive statistics we talked about earlier. The final module of the course, inferential statistics. So this is the goal. This is the ultimate goal of any statistics course is, okay, now we have our data. We've sampled our data. We've graphed it. We've come up with all these numbers, the mean, the median, the mode, all these other things. Now what? What does that mean in terms of drawing conclusions? So you see, a lot of these lessons are called testing hypotheses. And a hypothesis, loosely put, is I'm going to hypothesize that at least 50% of the population is going to vote for this particular candidate. All right? Well, what do? You gather data, you sample people, and you find out that, in fact, of the sample, the candidate has 46% support. So I'm going to hypothesize that it's 50% or more, and given that data, what's the likelihood that that hypothesis is true? And that's where the probability comes in. That's why we have to talk about probability prior to this. And so most of these lessons are testing hypotheses for the average of a population, for the percentage of a population. We can test two populations. We can test non-numeric data. So there's all sorts of tools we're going to talk about in that last module. So that's going to bring lesson number 1 to a close. Again, I wanted to give you just a very brief overview. Obviously, a lot of these terms are going to be unfamiliar to you right now. It may seem a little scary. That's okay. But I like at the very beginning to give you kind of a roadmap, because I think it's important. There's a lot of misconceptions sometimes about what statistics is. So I want to give you just kind of a roadmap, a goal to, and this is the eventual goal over here that we're going towards. So thank you for watching, and I'll see you in lesson 2, where we will begin our discussion of population and samples. I'll see you in the next lesson.